Hello, I'm Francesco from Intrepid AI, and in this tutorial I'm going to show something that we developed for a very recent hackathon we participated. It was the Battlefield of Things hackathon here in Belgium, and that was an amazing experience dealing with military and defense scenarios. So what we built for those 2 days was an algorithm for an autonomous swarm of defender drones with the objective of defending a so-called high-value target, which is an antenna placed somewhere in a city. And of course, we had also another assumption, which was an attacker drone. And so what we built was essentially a way to simulate these interactions by giving a human being the possibility to drive or to pilot or to fly, as they say, the attacker drone and trying to attack and succeed with that, attacking the high-value target. On the other side, there were, of course, the defender drones that were running a completely autonomous algorithm, a very reactive and adaptive one. And so the idea of that hackathon was to, showcase those particular features that we could build with the Intrepid platform. And so that's exactly what I'm going to show you now. So the very first thing is, of course, spawning the simulator and generating a few topologies for a virtual city. Let me see. We can use the CityGen to generate that. We don't need any drone. We start the simulation, and this is going to be our world, in fact, our playground. Okay. Now we go to the code, and we can see the world controller base that connects to the Intrepid simulator. And this is the code that creates the environment and the scenario and, of course, the behavior of the defender drones. So in this case, we need the world controller that is creating an attacker vehicle controller. Here we create the defenders. There will be 5 defender drones around the high-value target. And the attacker vehicle controller, which is the drone that the human will try to fly. The defender vehicle controller implements an algorithm, this control function, that is our algorithm, the adaptive and reactive algorithm for crashing into the attacker when it is intercepted. And so there will be coordination between the defender drones and in order to protect the high-value target, which is that antenna that you see there in the city. Now here we have the 5 vehicles plus the attacker vehicle. Here is Agent 1, which is one of the 5 defenders. Then we can switch to Agent 2. We cannot control these vehicles. They are there. And Agent 5. And then, of course, Agent 99. This is the vehicle that we can control. So I'm going to try. I'm doing my best to fly this drone and crash it to the high-value target. Hopefully, I would like the defender to protect that high-value target because that's the algorithm that we are testing. So I'm going towards the high-value target in a very simple trajectory, and I see already the defenders repositioning and intercepting me and crashing on me. So they protect the high-value target by just crashing on the attacker, which is brilliant. Now, of course, that was a simple trajectory. I was just flying straight to the high-value target. So I'm gonna replay the game, maybe with a bit of a more sophisticated trajectory, a more smarter trajectory. So let's see. So now, as we can see, the defenders are repositioning, and they are waiting that someone gets close to the high-value target to be intercepted. I'm gonna go to the left this time, and I see that the defenders are already repositioning, so they detected me. They're equipped with sensors, of course, to detect obstacles and vehicles. And now I want to try to go straight on the high-value target from the side, and I failed again. Which means that the algorithm is good because the defenders are doing a great job now at readjusting their positions and keeping the high-value target safe. All right, I don't want to give up. I want to try one more time, I promise. Third and last. So let me restart the simulation and of course restart the entire script. Okay, this time I want to use another strategy. I want to go up, increase my altitude. Hopefully they're not gonna detect me. Then I go a bit straight, then to the left, and then still high. I wanna avoid that guy already. He's trying to intercept me. I think I'm gonna do a better job than before now. I'm gonna go to the left and straight to the I value target. Let's see. They intercepted me here and they crushed me. Okay, well, I did not succeed. The defenders did succeed indeed, which is a good thing because that was exactly the type of the algorithm that we were testing, stress testing in this case. So as you can see, Intrepid AI can be used with the coordination of source code, your code, or other packages, and the simulator, and the controller, and the entire Intrepid stack in order to stress test. In this case was a coordination algorithm for autonomous swarms in the military and defense scenarios. So yeah, that's it for this tutorial. Of course, if you have questions, do not hesitate to jump on the Discord channel. We have a Discord channel. And of course, don't forget the link, the official website, intrepid.ai. See you next time.